Hi, my name is Rob Dodson. I'm a freelance front-end developer, consultant-y type person here in San Francisco. We're going to talk about tons of stuff this evening. So if there's not a lot of time for Q&A at the end, you can always hit me up at my blog on robdodson.me or on Twitter or on the GitHubs. We're going to be showing lots of really cool stuff in this presentation. I'm going to put these slides up for you all to mess around with. I'll throw that URL out at the end of the talk. But just in advance, if you want to mess around with any of the stuff that we're talking about tonight, you're going to want to have Chrome Canary. You're going to want to turn on some of these settings in your browser so that you can actually play around with all this technology. Because everything we're talking about in the talk is super new, super bleeding edge, crazy shit. All right. What are we going to cover? If you guys saw the announcement, we're talking about web components this evening, and some of you are probably, most of you are probably like, what is web components? I don't know what that means. So we're going to cover what the actual term means and what the whole component model for the web is. We're going to talk about all the new specs and standards that collectively make up web components. There is no one web component technology. We're actually going to be talking about 4 different technologies which kind of interlock like Voltron and become this amazing, awesome thing. And the last thing we're going to talk about is how you can actually use some of these things today in all modern browsers. Like, I always hate it when I go to a presentation and people are like, look at this amazing stuff. You can use it in 6 years. So everything that we're going to be showing today is stuff that you can use right now. Fair warning, there's going to be a lot of code in this talk. I've given it to designers before, and they've kind of just like glazed over halfway through. But I think if you hang in there, you're going to be really stoked about everything that we talk about today and everything that you learn. My hope is that you guys are going to leave tonight feeling like this. You're going to be really pumped by where the whole web platform is headed, where web components are headed, and everything that we're talking about. So I want to start things off by asking kind of a rhetorical question of the audience, because I think it really helps to set the tone and the context for everything that we're going to be discussing. And I want to know, for those of you who do use Twitter Bootstrap, how do you use Twitter Bootstrap in your app? I want you to think about how you get Twitter Bootstrap into your app. And it's OK if you don't use Twitter Bootstrap. It's OK if you have no idea what I'm talking about. It could be how to use Foundation, how to use Kendo UI, how to use jQuery UI, how to use jQuery plugins. Really what I'm asking is, how do you use all of the third-party code and widgets that you bring into your app? How do you go about that? So I'm going to go through this sort of narrative. And perhaps this will feel familiar to you, and perhaps this will help us illustrate some of the problems that we're dealing with today on the web. So if I want to use some third-party code in my application, typically what I do is I go find the documentation for that widget or that library or whatever. These are the docs for Twitter Bootstrap. So I find the thing that I want. And then I just copy a whole bunch of code, and I throw it into my app. Because they're like, oh, yeah, you want to use the navbar? Sweet. Grab all this HTML, throw it in your app, include our CSS. Voila, you get a navbar. You get this sweet little widget. But you usually don't want one widget. You usually want a bunch of them. You want a bunch of these like cool new widgets. So you go back to the documentation, and you find something else that you really like in there, maybe like a carousel, maybe pagination, something like that. And you grab all the code for that, and you throw that into your app. And you do this over and over and over again, so you've kind of built this application that's just full of boilerplate code that looks like this. It's all this sort of UI code that you yourself did not write, and so if you perhaps leave a line out, then the whole thing breaks, and you're wondering why it broke. And it also means that your app becomes sort of harder to maintain and harder to change, because you've just got all this stuff floating around everywhere. I think we can do a lot better than this. I think this is, right now, this is like the current best-in-breed way to build front-end applications is just go grab Bootstrap and throw it in there. I think that's a problem. I think what we're doing today is kind of the IKEA approach to building web apps. We're just taking a bunch of bits and pieces and cobbling it together, and sometimes there's things left over, and we're like, well, I hope I didn't need that. But we're just kind of gluing all this stuff together DIY-like. I think that this step right here is our main issue. Instead of copying all the things, I think it should look like this. I think it should just be use the thing. If I want a navbar from Twitter Bootstrap, I should just be able to use like a Twitter Bootstrap navbar tag. And then the only code that I'm going to write is going to be the code that actually pertains to my application. The only links that are going into that nav bar are the ones that I care about. And all that other UI code, I don't need to know about it. I don't need to know how the nav bar got created. I don't care. So this is the problem that web components are trying to solve. This is what we're going to be talking about tonight. OK, so the term itself, web components, it's kind of an umbrella term. It's actually a bunch of different technologies which collectively let us do some really awesome stuff. So first among those is it gives us the ability to create our own HTML elements. And we've shown that previously with that bootstrap tag. But that's not all it does. It also gives us the ability to encapsulate our CSS styles. So if we write some CSS and we put it into a component, that CSS is protected from the parent document. And it means that our component is going to render exactly as we intend it to. We don't have to worry about the parent document having more specific CSS or important tags or anything like that. It's not going to affect the rendering of our component, which is huge if you write a lot of CSS. Web components also give us the ability to react to changes in our component with lifecycle callbacks. So when someone adds one of our components to the page, when they take it out of the document, when they change an attribute on it, we have all of these JavaScript callbacks that we can run to react to those changes, render our component differently, fire an event, load some more data, whatever you want. So these are sort of the sexy high-level overview kind of like selling points of web components. But the most important thing about web components is that when we're working with them, when we're defining these new tags, everything that we're doing, all the syntax that we use, all the APIs that we use, are the exact same ones that the browser makers use when they implement their own tags. So when the team at Mozilla or the team at Chrome, when they are implementing the video tag, when they're implementing the text area tag, all of the APIs and syntaxes that they use to do that are now being exposed to us, the developer community. So these are first-class tags that we're building, and that's pretty wild and pretty insane. It also means that it's a very short hop to go from successful web component to new standard in the browser, right? And today we're dealing with huge problems where to add anything new to the browser takes years. It takes us like 6 years to add something new to the browser. The video tag was proposed in 2007. It's 2013, and I think there's probably some of you in the audience who still consider that like future technology. Like I'll use the video tag someday when like everybody's on board with the video tag, but not today. That's a problem. If we're trying to compete with iOS and Android in this sort of mobile space, and those libraries can evolve really quickly, we've got to be able to evolve quickly as well. So what are some cool things that we can build with web components? Let's imagine you're trying to build a data viz library, okay? And the way that you do that today is you write a whole bunch of JavaScript. The user needs to bring that into their application. They need to instantiate it, configure it. They need to pass it some data. They need to call some methods on it. They need to find a place in the document where your chart's going to show up. It's a lot of back and forth between your HTML and your JavaScript when you think about it. It would be cool if we could just have a pie chart tag. And in your page, you could say, hey, right here, I would like to have a pie chart. And voila, you would get a pie chart, And maybe you configure it with some attributes, but that's really like the extent of your interaction with the pie chart. You don't really care how the pie chart got made. You don't care about the library that made the pie chart. You just asked for a pie chart and you got it. Show of hands, how many of you have worked with or know what Markdown is? Most of you? OK. So Markdown it's a language for sort of pre-formatting your text. And if you've used Stack Overflow or GitHub, they use it for their comments. It's really handy. And it would be awesome if you could just have a Markdown tag and just start like writing your whole website in Markdown, right? Like, wouldn't that be awesome? And that's entirely possible. Like, this is an actual tag that I've made using web components that just renders Markdown. And imagine the cognitive weight that would take off of your mind if you were building the same sort of comment system that Stack Overflow or GitHub has. And instead of having to grab all the user's comments, turn them into Markdown, render it, put them back into the document, you could just say, hey, so long as the user writes Markdown over here, it's going to render. And I don't care how it happens. I just know it's going to. It's a lot less work for you to deal with. So that's kind of the why of web components. Hopefully I've sold you on the why of web components. Now let's talk about the how. And as I mentioned before, web components are an umbrella. There's no one thing that makes up web components. It's 4 different things, and you sort of use them all together. The first of those things is templates. Templates are how you scaffold out your component. It's the reusable bits that you're going to stamp out over and over again in the page. Next is shadow DOM. Show of hands, how many of you have heard the term shadow DOM? Not necessarily know what it is, but you've just like heard someone say it. Yeah. And it sounds really cool when they say it, right? Like you're like, oh, shadow DOM, yeah. So shadow DOM is how you encapsulate your component. It's how you guarantee that your CSS styles are protected. It's how you guarantee that external JavaScript is not mucking around inside of your HTML. Next, we have custom elements. So custom elements are how you extend the browser. It's how you extend the HTML language, really. And the custom elements are custom HTML elements. So the pie chart tag that I showed before, the markdown tag that I showed before, the Twitter bootstrap tag, those are all custom HTML elements. And lastly, there's imports. So imports is just how we take all of this stuff, package it together, and load it into our document. The same way that you import CSS or you import JavaScript, you can import custom elements. So here's the equation for web components that'll sort of give context to everything and help it all make sense. Keep this in your head as we talk about the different specs. You've got templates plus shadow DOM equals custom elements. You take a little bit of scaffolding, you put it in a little bubble where it's nice and protected, you give it its own tag name, and then you just import it into the page. So we're going to talk about each of these so you kind of know how they work. By the end of this, you guys will be able to write your own web components, which should be a lot of fun. Starting with templates. Templates are inert chunks of DOM that can be reused throughout the page. Basically, it means it's little blobs of HTML that you can just like clone and stamp out elsewhere on the page. If you've worked with libraries like Mustache or Handlebars before, basically the exact same thing, but now it has its own tag, this template tag that you can use in the browser. So when you're working with a template, you can put any kind of like valid markup you want into it. You can put paragraphs, you can put SVG, you can put canvas, whatever is like valid markup on the page. You can put image tags inside of it, and when you put an image tag in it, or anything that requires an external source, like a video tag or an audio tag, you can actually leave the source undefined while it's in the template. Because while it's in the template, it's inert, the browser doesn't really care about it. And the nice thing about that is you can then define that source at runtime when you like grab the guts of the template and stamp it out on the page. You can put JavaScript inside of a template, and that JavaScript is inert. It's just like sitting there. It's not going to do anything until your template goes live in the document. When you're working with a template, you just query selector the template tag itself, and then you ask for its content. So there's this new content keyword, and that's going to give you all the guts of the template, and then you can actually throw that onto the page. So using a template looks like this. Up here at the top, we've got the same template that I was showing a couple slides ago. It's got an image tag in it that doesn't have a source, paragraph, some JavaScript that's not doing anything right now. And then down here in this little script block, we're going to query selector the template. If you've used jQuery before and you're more comfortable with jQuery, document query selector is basically the same. It's just writing $. So we're going to query selector the template, and then using that content keyword, we can actually go inside the template and give that image tag a source at runtime. And then we can just append the content of the template to the document body. So when we run this, some things should happen. Let's see if I can run this guy. So our script block is going to go live because now it's been added to the page. The HTTP request for our image goes out and comes back, so our image loads. And then we see the rest of the content of our template down there. So it's just like stamping out a template using any other library that you've worked with before. There's a few gotchas when you're working with templates. First, there's no built-in data interpolation, which means if you're used to libraries like Mustache and Handlebars, you know that in those libraries you can have like a JavaScript or a JSON object on the page, and you can just use little curly brace tags to like pipe the data from that object into your template. Native templates don't do that. The browser makers wanted to leave that process up to us, but I say it doesn't like work yet. There's already libraries which have added this functionality, so it's there. It's just not there natively. The other thing to know about templates is that nested templates do not automatically activate. So if you've got a parent template, child template inside of it, you take that parent and you like stamp it out on the page, the child template does not suddenly start working. You've got to actually query each of them separately and append them to the document separately. Okay, so that's templates. That's the first part. That's how we scaffold out our new components. Now let's talk about Shadow DOM. Shadow DOM is a beast. Like, there's no way that we can even cover a fraction of what it actually does in this talk. You could have an entire conference about Shadow DOM, and there will be conferences just about Shadow DOM in the next few years. But what we're going to do is we're going to talk about the high-level stuff so you can at least start being productive with it, and you can start like poking around with it and understanding generally how it works. You might feel like that at the end. In a nutshell, Shadow DOM provides style and markup encapsulation. You take some HTML, you take some CSS, and you put it inside this little bubble, and you decide which bits are going to be public to the user and which bits are going to be private, which bits like people aren't going to be able to access. And as I mentioned before, the really cool thing about Shadow DOM is that it's the same technology that browser makers use today when they implement their own tags, like video and like text area. So let me give you an example of how that works. We got a video tag up there, and when you use a video tag, you just need like one line of HTML to make it show up. You're like, yeah, I want a video. Here's the source for the video. I want it to have controls, so I'll use this controls attribute. But if you think about it, you're getting a lot for just that one tag. Not only do you get the video player, but you get a play button and a scrubber and a time code and a volume slider, all this stuff, right? And you didn't write any markup for that. It just kind of showed up. And you're like, oh, sweet. Well, that's awesome. I'm glad that I get that for free. What's actually happening, if we open the dev tools, if you open the Chrome dev tools, and I'm going to embiggen these so you guys in the back can see. So I'm trying to make them huge. So you click on this little gear here, and inside the dev tools, if you scroll down, you'll find this thing that says Show Shadow DOM right there. Turn that guy on, and then you can go and inspect your video element. So here's our video. It's kind of squished in there, but that's our video tag. And we can actually open it up. And there's this grayed out document fragment in here. And it's like, what's that thing? And there's this div in here. And as you sort of work your way deeper into the video element, eventually you'll see, oh, hey, like here's the play button. And like here's the scrubber. Here's all the internals of my video player. And the browser makers have just implemented them with HTML and CSS. But they've hidden it from us. They've like put it inside of this weird gray document fragment thing. And I don't normally have access to that. I usually don't see that thing. So this is the Shadow DOM. This is this secret place that the browser makers previously have only had access to, where they could hide markup and hide CSS. And the reason why they created it was because they needed a way to guarantee that every time you used a video tag, that it would look the exact same, regardless of what you already had on the page. So they needed a place where they could hide all these things. And they've actually been using it for a really long time. Like inputs, text area, you know how they also have kind of like a little bit of like styling to them? It's also because they're built using the Shadow DOM. So when you're working with the Shadow DOM, there's like a few terms that are sort of important to know. The first is that the element that's hosting all the Shadow DOM is known as a shadow host. This first little document fragment in here, it's called the shadow root. That's the first descendant of the shadow host. Inside of the shadow root, you've got all these divs. Those are all called shadow nodes. And the whole thing is protected by this little barrier called the shadow boundary. And the shadow boundary is what prevents CSS from like bleeding across. It's what prevents JavaScript, like external JavaScript, from traversing around inside of here. If someone's using jQuery to look for like every div on the page, they probably don't want the divs inside of here, because we've like explicitly said that you shouldn't touch those. So the shadow boundary is what ensures that separation. So just to like reinforce this visually, the shadow host is the element like holding all the Shadow DOM. In the previous example, it was the video tag, or it could be like a text area tag, input tag, or a tag that you define. The shadow root is the first node in the Shadow DOM. It's that grayed out document fragment. And the whole thing is protected by this shadow boundary, and that's what's keeping external CSS out, and it's keeping external JavaScript out. So conceptually, these are the main things that you need to keep in your head when we're talking about Shadow DOM. Creating your own Shadow DOM is actually really easy. You just, every like HTML element now has this new method, create shadow root, so you just call that on your element after you've selected it. And I'll show you how to do that. So To start off, we've got a little div here. I'm going to give it a class of widget and put some text inside of it. So that's this guy down here at the bottom. It says hello world. And then in the JavaScript, we just query selector that div. We ask it to create a shadow root. And then we set the inner HTML of that shadow root to a string of HTML. We're going to have like an emphasis tag that says, like, I'm inside your div. So if we run this, you'll actually see hello world is going to change to say I'm inside your div. And if we actually inspect it, we can open it up. And just like the video element, now we have this grayed out document fragment. And inside of there, we have that little tag that we wrote, this I'm inside your div tag. So we've taken some content and we've like hidden it in the shadow DOM. Can you guys see that okay? Now, here's something that's important to note. Hello world, the original text content that we had in there, it did not go away. We did not like destroy it or obliterate it or anything. It's still there. It's just not being rendered by the document, or sorry, by the browser. And that's a really important distinction to keep in your mind, that only descendants of the shadow root, only the stuff in the shadow DOM actually ends up being rendered by the browser. And so we're going to talk later about how you can actually like pull things out of the shadow host and into the shadow root, because you definitely want that. But for now, keep this in mind, because it's a really important distinction to know. All right. So I mentioned that when you're working with CSS in the shadow DOM, that the styles that you use are protected. This is crazy. To me, this is like the coolest thing about shadow DOM. And if you've ever written a lot of CSS and you've been frustrated by like CSS specificity and all these other things, this should make you feel better about the future of your job. So here we got a template, because we're gonna put a template into the shadow DOM. That's totally cool. That's actually a very good thing to do. Inside of the template, we got a style tag. In the style tag, we're going to say, hey, I think all H3s should be white with a background of tomato. Okay? And tomato is like a built-in CSS color. It's not something fancy that I did. And then we've got an H3 inside of our template that says a shadow H3 header. So we're going to take all of that and we're going to put it in the shadow DOM. Do that. We query selector the template. We query selector our little widget down there. We ask the widget to create some shadow root. And then we clone the guts of the template and we throw it into that shadow root. Okay? So what we get is this thing at the bottom that says a shadow H3 header. And you'll notice that the text is white, the background's tomato. And the other thing to notice is that right above it is an H3 header that just is like from my presentation. And the two look nothing alike. The two are not affecting one another. Even though I have a style tag and I've thrown it into the document, that guy right there did not suddenly like turn white and get a background color. And likewise, this guy down here is not using that typeface. So they're completely separate, and that's thanks to our friend, the shadow boundary. Now, when you are working with styles in the shadow DOM, there's a few really like high-level flags that you can use to affect how you think styles should be interpreted and inherited and whatnot. The first is called apply author styles. This is like a Boolean value that you set on your shadow root. By default, it's set to false, and it means that it's not going, like author styles, any sort of styles in the parent document are not going to be implemented in the shadow DOM. They're not going to render. If we set this to true, if we like toggle this to true, then it's going to allow those styles to come into the shadow DOM. It's going to allow the styles from the page to start affecting our elements in the shadow DOM. So my H3 header starts to use the same typeface as my other H3 header. It starts to use the same margining as my other H3 header. My style tag, where I set it color to white and its background of tomato, that is also being applied. But I'm now inheriting author styles as well. So that's apply author styles. It can be true or false. By default, it is false. The other one is reset style inheritance. So again, you set this on your shadow root. This is also false by default. If you set reset style inheritance to true, it's kind of like turning on the ultimate CSS reset. Have you guys used CSS resets before, like in your apps, right? So while my H3 header is not using any of the styles, my shadow H3 header, this guy down here, is not using any of the styles from the H3 up there, it is still styled, right? Like, it is centered, for instance, And it's not using that typeface, but it is using the same typeface as all my body text. So it has inherited some styles. But if you set reset style inheritance to true, it's going to like reset everything right at the style boundary. So now it goes back to being left align, and it starts using times bold, and it's like 18 point or whatever. This is like the browser default. My style tag is still being applied, but everything else has been reset. So that's reset style inheritance. Pretty cool. Other interesting things that you can do. Remember how I said that the element hosting all of our shadow DOM is referred to as the shadow host? So we can actually style the shadow host from within the shadow DOM. This is good if you want to add like rollover behavior and stuff like that to whichever element is holding all of your content. So there's a new CSS selector. It's this like :host selector, and you can use that to actually style the element holding all of your shadow DOM. The host selector is a like functional selector. It takes arguments. So you can say, hey, if my shadow host has a class of skinny, or if it is inside of an element with a class of skinny, I want you to apply certain styles. So you can use this to like theme your component. Depending on the context in which it is being used, whatever an element is sort of nested inside of, it can change its appearance, which is pretty interesting. You can also use what are known as custom properties. So inside of your shadow style tags, you can say, hey, I think H2s should use a font family, and I'm going to set it to this variable. This is like CSS3 variable syntax. So I think my H2 should use a font family of variable header font. I'm not actually like specifying what the font family is. I'm just exposing a variable. And in the parent document, someone can implement that variable and say, oh, cool, I think var header font should be Courier. And that way, they can actually reach into the shadow DOM and style something that I've exposed to them. But they don't have to know the particulars. They don't have to know the inner workings of my, my shadow DOM, which is really handy because it means that you can expose like sort of a limited set of variables for people to mess around with. But then you can change the internal structure of your shadow DOM all you want. You can mess around with the HTML all you want, and the user's, the user end, it's never going to break. Okay, so that was styling. Let's talk a little bit about content. So I mentioned before that you can pull content from the shadow host into the shadow DOM, and you might want to do that, for instance, if you're building a button, and you might have a button with like really elaborate markup in the shadow DOM, but you still need the label for that button to come from the user. So to do that, you can create an insertion point using the new content tag. Insertion points look like this. Inside of your template, you can say, okay, I've got an H2, and inside of my H2, I want a wild content to appear. And whoever is actually using our element can then just pass in some text. They can say, oh yeah, widget should have Jigglypuff inside of it. So when the browser composes these two, you end up with a wild Jigglypuff appeared for the Pokemon fans. The content tag by itself, it's kind of like a catch-all. It's basically saying, hey, any content that you have inside of the shadow host, I would like for you to try to render that inside of the shadow DOM. That means you could have like 1,000 lines of HTML inside of this widget div, and it would try to render all of those. You probably don't want that. You probably want more granular control over how content appears inside of the shadow DOM. So you can actually give your content tag a select attribute. And with the select attribute, you can use CSS selectors to pick and choose which things you want from the shadow host and where they should appear inside of the shadow DOM. So that looks like this. Up there at the top, we've got a few H3s. It says like last name, content, select anything with the class last name and render it right here. Select first name, content, select anything with the class first name. And then here I've got a content tag that's selecting with empty quotes, which is sort of like a wildcard. It just means any other content that was not selected, try to render that right here. When the user is using our shadow DOM, they can say, okay, here's my widget div. I'd like it to say hello world. I've got a span here of class first name Rob. I've got a span here class last name Dodson. Throw that into the shadow DOM. The interesting thing is that when it renders according to everything that we listed in the shadow DOM. And since we used content selection and insertion points, we can actually totally rearrange the way the source actually appears. So we've basically like flipped the order that everything is rendering out of the host into the shadow DOM. This is really crazy and it's really powerful because it means that the user doesn't have to put things in the right order. It means that so long as they use the right class names or like IDs, we can just choose how things will render for them. And that's really powerful because it means that the user could swap out one shadow DOM for another, and so long as it's by the same author or whatever, it could completely change the appearance and they never have to touch their source. Okay, conceptually, I know everything that I just said over the past like 3 minutes was a total mindfuck. So Eric Beidelman from Google put together a wonderful tool, this Shadow DOM visualizer, which will actually let you write Shadow DOM and write like host node HTML, and it will just show you where everything ends up, which is really useful when you're first getting into this and you're like, okay, I think I understand how this works, but I have no idea actually how this works. So this is a really handy tool when you're first getting started. After you've done this a few times, though, you'll learn to just like intuit this, and it is not as confusing once you've worked with it for a little while. And one last thing that I want to show, this is like brand new, so this just landed. You can actually style into the shadow DOM from the outside using two new CSS selectors, one called the hat and one called the cat and the hat selectors. So I know I said that the shadow boundary makes sure that the user can't like accidentally like get in there and start styling your element, and that's true. They can't accidentally get in there and start styling your element. But you do want to allow them the ability to reach in if they absolutely need to. So that's where the cat and the hat selector come in. So the hat selector, this guy, this like single caret guy right here, will go one level deep into the shadow DOM and allow you to apply a style there. And if you remember our content tag from before, right? Like you can take content out of the shadow host and render it in the shadow DOM. So that means you can have shadow DOM inside of shadow DOM. You can have like a shadow DOM inception going on. And that's where the cat comes in. The cat will let you pierce through every layer of the shadow DOM and style all the H2s inside of it. So cat in the hat. That just landed in like Chrome 33, brand new. So you guys are the first to know. Okay, so that was Shadow DOM. That was a lot, I know. Thank you for hanging in there. Let's talk about custom elements. Okay. Custom elements are new tags that we create that extend what the browser can currently do. If you remember the equation from earlier, templates plus Shadow DOM equals custom elements. So this is the part that we're getting to. You got a template. You're hiding all this stuff in the Shadow DOM, just like the video tag, right? You've got this like cool one-liner of HTML that people can use. Now let's just take it a step further. Let's just define our own tag for it. So to do that, we use the register method, which is a brand new method that's been added to the document object. And you call document register. You pass in a tag name for whatever your new tag is. And you need to pass in a prototype, like a JavaScript prototype for it. There's two requirements. One, the tag name must have a dash in it. So it's got to be tag-name or x-foo or my-widget. That tells the browser, hey, this is a custom element. This is not like a native element. And that's to prevent someone from accidentally like naming something that later on the browser makers want to use that name as well. So that's kind of how you namespace your element of sorts. The other thing is that your prototype must inherit from HTML element. And I'll show you how to do that. That sounds complicated. It's not. Okay, so to create our custom element, the first thing you want to do, you want to have a template. You want to have a template full of cool stuff. In this case, we're just showing that you would like query selector or some template somewhere full of markup. And then you need a prototype that extends HTML element. So you can do that using object create. You can say, hey, I want a new prototype. And using object create, I can just extend HTML elements prototype. That's really the extent of it. You don't have to worry about like complex JavaScript inheritance. I know that's a confusing topic. This is all you got to do, this one line right here. On this new prototype that you're creating, you need to have this one callback, this created callback. This is like when the parser is working its way through the document and it sees our tag, it's going to check to see if it has this created callback defined on it. And if it does, it's going to run it like as soon as it sees it. So this is where you kind of do all the setup work for your tag. And what we're going to do here is we're going to create our shadow root, and we're going to append the contents of our template to the shadow root. Okay? We're just going to like make sure something displays. The last thing we do is we call document register. We pass in our new tag name, we pass in the prototype that we've just defined, and we have like a new tag now. So using it, really straightforward. We can just use our new tag name because we've registered it. We could also do document create element and pass in our tag name the same way that you do document create element image or div. And we could also call new widget. So when we call document register, it actually returns a constructor to us. If we choose to expose that to people, they can just call new widget and add the element to the browser that way. All right. We talked about the created callback, which the browser runs as soon as it sees our tag. There's other really cool, handy lifecycle callbacks that we can use to build up, deconstruct, manipulate our component. There's the entered view callback, which gets run whenever one of our elements is actually added to the page. There's the left view callback, which is run whenever one of our elements is removed from the page. And both entered view and left view were previously called entered document and left document. You'll actually see a lot of tutorials out there that use that nomenclature. Don't use that nomenclature. It's being removed. The last thing is the attribute change callback. And this is really handy. So anytime someone manipulates an attribute on one of our tags, it's going to run this callback, and we're going to get the name of the attribute that changed. We'll also get the old value and the new value. So we can react to someone like manipulating one of our components. You can also extend pre-existing tags. You don't always have to just create a new tag from scratch. You can extend a pre-existing tag, and when you do that, it's called a type extension element. So if you want to just extend the button tag, you could still just call document register. You still got to give it a tag name. And then you pass in this extends option. So you're like, it extends the button tag. And the prototype that you pass in needs to be the prototype for that element. So HTML button element instead of HTML element. And then using your type extension element, you can say button is my button, or document create element button my button. It really depends on how you prefer to work with these elements. If you want to inherit all of the things that like anchor tags give you already, then maybe do a type extension element. If you want to create your own tag from scratch, that works as well. Yes? Question?
If you're extending an element that already exists, why would you have to specify its prototype? Shouldn't it be able to know that it's there and just use it automatically unless you want to override it?
Yeah, that's a good point, actually. Yeah, like when you say extends button, well, I guess it's because you could also extend like a custom element that you've already created. This might just be laziness on the case of the browser makers. That's a good question. Yeah.
And what do you have to specify it again when you create the element down there?
Oh, I don't know, because yeah, it seems like you should be able to just say my button, but again, that might just be something that the browser makers put in because they preferred that syntax.
I mean, what's weird about this to me is why is this different from the other one? Like once you create the element, shouldn't it be registered? I mean, should it be the same as any other?
So in terms of like, okay, so why would you extend something? So you can inherit all the things that it has, like href and things.
I'm not asking why you would extend it.
Yeah.
I'm asking why is it not the same
Right.
as the custom element?
I don't know. You'd have to ask Google. Yeah. Okay. So one thing that you will see in a lot of examples is people creating custom elements like this, where they do it declaratively. They use an element tag. This is something that was briefly added to the browser, where you could just have an element tag, and they could have like templates inside of it and do a bunch of other stuff. This has been removed. Like every tutorial I see creates custom elements like this, and this has been removed. So if you guys are like researching this afterwards, and you're like, oh, hey, this looks like the much more straightforward way of doing it. It totally is the more straightforward way of doing it, but it was taken out just because they were having problems sorting out the execution of when all the JavaScript would happen, or the order in which all the JavaScript would execute. Okay, let's take a break. Okay, we are past all the painful code for a little while. Okay, let's look at some cool stuff. What could we build with custom elements? What could we build now that we have access to the ability to define our own tags in the browser? So I use MailChimp on my blog for people to like sign up for my newsletter. These things look very distorted on here. Normally it doesn't look so crazy like that, but if you've used MailChimp, if you use Wufoo or some other service like that, they give you a whole big blob of HTML that you need to add to your page. They give you a whole bunch of CSS, a bunch of JavaScript that you need to add to your page, and you just gotta like chuck that into the bottom of every page, right? that kind of sucks, especially if it doesn't look like the rest of your code. Maybe they use underscores instead of dashes or something, stylistically you don't like it. So I created a MailChimp tag, and all it does is it takes all the MailChimp stuff and it just squishes it down into one tag. And it's close to a one-liner. It's much less code than what I normally have to work with when I'm using MailChimp. If you do data visualization, there's a lot of back and forth between JavaScript and your markup on the front end. It would be cool to just have tags like this where you could just specify, hey, I want a pie chart, donut chart, bar graph, and you just configure them with values attributes. So you can pass in an array of attributes, and that will just like set the way those tags look. And what if it wasn't like UI at all that you were working with? What if you wanted to work with more behavior type stuff? So there's a library out there called Moment.js, and it's really cool. It basically takes a string of text and converts it into a date object for you. So you could pass in October 31st, 1983 or something, and it would just turn that into a JavaScript date object, right? So I was thinking, OK, cool. Let's make a moment now tag. Let's just like encapsulate that behavior into a moment now tag. So we can use the date object like in a paragraph, and we don't have to write any JavaScript for that. And then I was thinking, OK, cool. Let's take the moment now tag and let's just nest it inside of a moment format tag. So the moment format tag, the only thing it cares about is that its first child exposes a date of some kind. And then it can configure that date using these tokens. And since moment format has a consistent API, the only thing it cares about is that its first child exposes a date, you can have a moment parse tag. And the moment parse tag, someone can actually pass in text, and it will turn that into a date object. And you can actually combine like all of these into a moment from tag. So the moment from tag just wants to see whatever two children it has inside of it. So long as they produce dates of some kind, it's just going to find the difference between those two dates. So the cool thing about this is it doesn't even have to be like the moment library that you're using. So long as you expose a date in the same way that the moment from tag like knows to consume them, you could have different tags inside of there. But this is kind of like some of the weird, crazy stuff that you can start to do when you're not even thinking about UI anymore. You're just like, what if I just started putting JavaScript inside of here? Like, what happens? So pretty interesting. So everything that you see on the screen, no JavaScript was written to make any of that happen. That's all just like paragraph tags and those tags down there. OK. Last thing we're going to talk about is imports. And this will be really quick. Imports load external documents into your page. It's basically how you pull in custom elements, right? Now, working with an import is super straightforward. You use a link tag the same way that you use a link tag when you're working with CSS. There's just a new relation type. So normally you say link rel equals stylesheet. Now you say link rel equals import, and you point it to some HTML file that you would like to pull into your document. Using imports, very easy. In your head, you just link to whatever HTML file you're pulling in. That's the actual like import that I used to pull in all of those charts that you saw. And then you just use your tags. There's no waiting to see if they've loaded. There's no like async checking that needs to go on. You just use your tag. You can assume it's there the same way that you can assume CSS is there, which is really handy. So that's it. Collectively, these are the technologies that make up web components. Now the support is spotty, for sure. Google Chrome has everything that you need. Firefox is working on a lot of this stuff. They've actually got an open ticket to implement Shadow DOM, and it seems like they're like halfway through that. IE is IE. And then Safari has some of this stuff in it because it was originally in WebKit before Blink and WebKit forked. So it's like in Safari, and I know that recently they've been participating on the mailing list, and they've been like, all right, let's talk about these custom elements and everything. So it sounds like Apple is interested in this as well. If you want to play with this stuff now, though, I'd recommend using Chrome Canary. You need to go into About Flags, and you need to turn on all these different like experimental features. And make sure to turn on Show Shadow DOM in the developer tools, like I did that earlier, if you recall. And that's if you want to do native web components, which is awesome, and I highly recommend it. But I don't want you guys to like come into this talk and be like, well, great, like I guess I'll use this in 10 years. I wanted to show you how you can use them today in all modern browsers. So to do that, there's this really cool library from Google called Polymer. And Polymer is a collection of polyfills, which let us use all of these web components, everything that we've talked about today, in all browsers, all modern browsers. That includes IE 10 and above, Safari 6 and above. Mozilla has a variant of this library called Xtags, and that works all the way down to IE 9, but it doesn't have all of the additional features of Polymer. If you don't know what a polyfill is just a collection. It's a JavaScript library that sneaks support for a cool feature into a browser that does not support it. So, IE, basically. Now, if that was all Polymer did, that'd be really cool, but Polymer is also a framework for building web applications. So it adds all the cool web component stuff, but it also adds all of these new technologies, all of this stuff which is, some of it is being standards that are being debated right now. Some of these are just total future things. They're not even drafts yet. We get web animations, pointer events, template binding, node binding, and model-driven views. A lot of really cool, really powerful stuff packed into this framework, including all the web component stuff. And using Polymer to declare your own custom elements is really easy. It's a lot easier than doing it the native way. You just include Polymer, and then you have a new element that you can use, Polymer element, and you can give it a tag name, whatever name you want. So up there it's my element. I don't know. Is that me? Maybe it's my head. You can put a template inside of Polymer element, and Polymer is smart enough to know, oh, if there's a template inside of this tag, I should just turn it into Shadow DOM. So it'll just do that for you, and you don't have to write any JavaScript to make that happen. And then you can just use your element. You're off to the races. So this element down here, hello, I'm on Polymer element. That is using this Polymer tag. When you are using the Polymer element tag, you can create attributes, and you can expose these to the user, and these become automatic bindings within your tag, which is really neat. So here it says, I've got a tag called favColor, and I'm exposing an attribute of just color. Inside of my template, I can say, okay, hey, I want an H2, and I want it to say, my favorite color is, and then I'm going to use curly braces to actually bind to the value of that attribute. And then in the script tag, I'm going to call the Polymer constructor. I'm going to pass it the name of my tag, and then I'm going to pass it a prototype object that's going to have a default value for that color attribute. So when the user actually uses our tag, it's going to say, okay, cool, I want this favColor tag. I want to set color to purple. And that just shows up, and we don't have to write any glue code to make that happen. The bindings just work, which is really cool. What's also really interesting about these bindings is that they're live two-way bindings. So as they change, the element changes. And again, you don't have to write any code to make that happen. It just happens. So here it says Polymer element. The name is color picker. The attribute that I'm exposing is, again, that same color attribute. Inside of the template, I've got this little span down here, and I've got this input down here. I'm going to bind the background color for the span, the text value for the span, and the text value for the input all to that color attribute. So if I go over and start typing in here, I can change it from tomato to sky blue, and as I'm typing, it's just updating inside of my element. Or I think burly wood is a really cool built-in color, or papaya whip. So you don't have to actually do anything to make these bindings update. They just update for you. And if you've seen demos of Angular.js, maybe this starts to feel very familiar and look a lot like their demos. And in fact, there is a lot of overlap between Angular.js directives and web components. And there's a lot of talk between those two teams about having the projects kind of maybe conjoin in some fashion. Okay, where's my cursor? Here we go. So the last thing you need to know is that when you're working with Polymer, you still have the same lifecycle callbacks which you can use to react to changes. The Polymer team shortened the name of them. So instead of created callback, it's just created. Instead of entered view callback, it's entered view, left view, attribute changed. Okay, there is way more on this topic than what we're going to have time to cover tonight. So To continue your further education, if you're like really interested in this stuff, I would recommend that I'm going to post these slides up for you all to go see. Definitely check out Web Components Resources. That is kind of like the one-stop shop right now to learn all about web components. It's Eric Beidelman from Google collected all the resources into one page, which is very handy. HTML5 Rocks has awesome articles on web components. Check out the Polymer project. Check out Xtags from Mozilla. It's similar but different from Polymer. Brick is a whole bunch of UI elements that the team at Mozilla has already created that you can actually start playing around with, which is really fun. Custom Elements IO is like a registry that people have put together of Polymer elements, Brick elements, native custom elements. So you can go there and you can browse what people are already making. And lastly, check out the Chromium dashboard because it has the status of all of these different specs, not just in Chrome, but also in Firefox, IE, Safari, etc. If you're interested in like any of the components that I showed in this talk, they're all up on GitHub. Fork them, break them, do whatever you want, go crazy. Just like don't launch them into production unless you're a crazy person. And yeah, thank you guys. Yeah, thanks. I hope you're leaving here excited by where we're headed with web components and by where the web platform is going to be in a few years. So thanks.